Let's take a look at the law of cosines involving an oblique triangle. So let me draw just a general oblique triangle, which means that there are no 90-degree angles. So at the bottom left here, let me call this angle A, and then moving clockwise, we'll have angle B and then angle C. So the sides opposite will be their lowercase letters. And just be really careful with lowercase c because it looks a lot like uppercase C, so make it really look small. So the law of cosines, there's actually 3 of them, but if you know one of them, you know all of them. So let's say I want to find side A. So we're going to have a squared, and it kind of starts out like the Pythagorean theorem. This is going to be the square of the other 2 sides, so b squared plus c squared. And then we're going to take off twice what you just squared, the product of b and c. And then this is multiplied by the cosine of the angle opposite of the side you're looking for, so angle A. Again, if you know this one, you know the other ones. Let's see if we can follow the pattern. So if I want to find side B, so we're going to have b squared equaling the square of the other 2, a squared plus c squared, minus twice what you just squared, so twice the ac, multiplied by the cosine of the angle opposite of what you're trying to find. And then one more, let's do for c squared. Again, starts out like Pythagorean, so c squared is a squared plus b squared. Then you take away twice what you just squared, times the cosine of the angle opposite of the side. But again, if you know one of them, you know them all. So let's look at an example where I give you 2 sides and an angle, more specifically the angle in between them. So in this example, let's say we have side A is 2, side B is 3. Okay, so we have A and B. So then the side angle in between them would be angle C is 60 degrees. Okay, now you can tell immediately that the law of sines will not apply because I don't have an angle with a corresponding side. So there's no way the law of sines is going to work here. So I'm going to have to use the law of cosines. Since I have angle C, I'm going to use the third one because I have angle C. So I'm going to use the c squared equaling a squared plus b squared minus 2ab cosine angle C. You can just fill everything in. So c squared is equal to 2 squared plus 3 squared minus twice times 2 times 3 times the cosine of 60 degrees. Okay, clean this up a little bit. So c squared is equal to 4 plus 9 minus 12. Cosine of 60 degrees is 1/2. So I get 13 minus 6, or 7. So c squared is 7. So that means that c is square root of 7. And rounding that, it's about 2.65. Okay, so now I have all the sides. Now I just need to find one more angle, because once I find that second angle, I can easily find the third one. So since I have angle C, I need angle A and B. Maybe I'll start with angle A. Now you have 2 options at this point. Since I now have an angle with a corresponding side, I could use law of sines. But anytime you use law of sines, you have to be careful because when you go to find an angle, you got to do the inverse sign, which means there could be 2 possible answers. So I'm going to avoid that altogether and just stick with law of cosines all the way through. So since I have angle A, I'm going to use the one involving side A. So side A squared equals b squared plus c squared minus 2bc cosine angle A. Okay, fill in everything you got. So A was 2, so 2 squared equals 3 squared plus c squared. We actually know that is exactly 7. Minus 2 times the b, which was 3, c, which is square root of 7, and then cosine of angle A, which is what we're trying to find. Okay, so solving for cosine of A might be a little easier if we clean this up a little bit. So I have 4 equaling 9 plus 7 minus 6 square root of 7. cosine of angle A. So the cosine of angle A will equal 4 minus 9 minus 7. You could have put 9 and 7 together. Just trying to come up with a pattern here. So subtracting the 9, subtracting the 7, so then you're left with multiplication. So then I'll divide by the negative 6 square root of 7. Okay, so if I wanted to find that, it was just simply a squared minus b squared minus c squared divided by negative 2bc. That's how I found cosine of A. So then A is going to equal the inverse cosine of all of that. Okay, be careful when you go to put this in your calculator. Since I have 3 terms on the top, you need to separate that by parentheses. Same thing on the bottom. If you have the nice feature on your calculator where you can activate the fraction, I definitely would recommend that. And you can see if you do, if you have a graphing calculator, by selecting F1. So that's going to be alpha and then the y equals. So because I have this numerator over denominator, I can use that. Okay, so I'm going to show you both ways in case you don't have that feature. So inverse cosine, and I'm going to activate my fraction. So 4 minus 9 minus 7 over negative 6 square root of 7. It's going to give me 40.89 degrees. If you don't have that fraction capability, you'll just have to separate everything out. So you'd have inverse cosine of parentheses, 4 minus 9 minus 7, divided by parentheses, negative 6 square root of 7, goes out, get the same thing. Okay, either way, doesn't matter. Okay, so that's angle A, and I had angle C, so now I can easily find angle B by doing 180 minus that given 60 minus 40.89 degrees. Okay, so 79.11. I'm going to write approximately because angle A was approximated. Okay, so again, anytime you don't have an angle with the corresponding side, you can't use the law of sines, so you're going to go to the law of cosines.